This talk is discussing exposure and vulnerability, tools, techniques, and opportunities. And this talk really intends to provide an overview of some of the data that we're trying to capture using new and emerging technologies, such as crowd counting cameras, as well as a number of other approaches, including traditional non-technology approaches as well. To start, I really want to conceptualize the risk of drowning and injury. As has been mentioned in some of the previous sessions to date, we really need to ask ourselves, what are the problems? What are the questions? What are we trying to answer before we just delve straight into technology? We want to ensure that we have a clear purpose, and that purpose can be solved by technology or some other means. In terms of the risk of drowning and injury, within a conceptual framework, I see three key elements or three key components that contribute towards the risk of drowning and injury. First of all, the hazardousness of an environment. So beach morphology and hydrodynamics and how they influence the physical risk of drowning and injury. Secondly, we've got the exposure element, namely the volume and frequency of water use, which is going to be the key component we'll be discussing today. And thirdly, the vulnerability component. So the hazard awareness, behaviours and competence of various people using the aquatic environment. As mentioned, I'll largely cover exposure element to start with, and then I'll touch on some vulnerability sections towards the end of this talk. So in terms of understanding what data we should be capturing, we first need to ask ourselves those questions. What questions do we actually want to answer with our technology or with our methods or techniques? Do we want to know a broad idea of the number of people using beaches? Do we want to know the overall number of people using that environment, or do we want to break it down by beach users and water users? And do we want to know how this changes across the season and across the hours of the day? So there's some real key considerations or elements that we want to pull out of this in terms of the method and the technologies that we use. What is the spatial scale and the temporal coverage that we want? Really critical components. What level of accuracy do you want? Do you want it to the nearest couple of people or to the nearest couple of hundred? What sort of resolution do you want? And how much money or resources do you have to put into this approach and this technique? Really critical questions to ask yourself when you go down this path. So I'm going to provide an overview of a number of methods and technologies for capturing exposure data. We've got on-site counting undertaken by dedicated personnel or surf lifeguards, through to other techniques such as car counters, Wi-Fi or Bluetooth sensors, imagery from closed-circuit television cameras, which Jason and Chris will discuss in detail later in this session, counting images from unmanned aerial systems, or some larger scale options in terms of high-resolution aerial imagery, satellite imagery. So the first of these techniques, I guess, which is really the traditional approach that's been undertaken in the coastal zone, is counting by personnel, by surf lifeguards, by surf lifesavers. It's really what we've been doing ever since these services have been provided. I would suggest these techniques are accurate where there are a small to moderate number of beach and water users. However, when those numbers increase, so too can the errors or inconsistencies in how that's being captured. Because these naturally coincide with days that are also busier in terms of activity of lifeguards undertaking preventative and rescue activity on the beach. These techniques, however, are limited to the spatial and temporal coverage of where and when your services are provided. Therefore, you don't know what is happening outside of hours at your patrol beaches, nor what's happening at unpatrolled beaches, even if they may be nearby. However, these approaches can provide a really cost-effective solution. Services are already being provided to the community, and this is an additional approach of information that they can capture while that service is being provided. However, we do have a number of, I guess, issues in this space, namely the consistency between different surf lifeguards or surf lifesavers in terms of how they capture that data, as well as the area of coverage. Are you counting just the area around the red and yellow flags for those that use red and yellow flags, or are you counting the extent of the beach? Are you counting just beach and water users, or are you breaking that down into further categories such as swimmers and surfcraft, for example? Over and above this, there is the option to obviously use researchers. These researchers, and this has been done in some cases, are going to capture data more accurately. However, it is going to be fairly resource intensive in terms of cost and time. Another approach that has been used in some cases are the likes of car counter technologies, Wi-Fi or Bluetooth sensors as well. These technologies typically target a site or sub-site scale, and they largely estimate the number of users of a particular site at the points of access. So where there may be one road in to a particular beach, using a car counter on the road, such as the one in the image here, can be an effective way to capture some information across the course of the day and across the season very simply. However, these are estimates. The estimate being that we don't know how many people are in each specific car. Likewise, Wi-Fi or Bluetooth sensors can be used at that subscale approach at beach access tracks. However, some of these approaches require you to have your device on you to pick up and sensor that someone is walking through, which also has its inconsistencies. Furthermore, with these techniques, there's an inability to actually distinguish between beach and water users. All we may know is that there's 200 people in this environment, not if they're on the beach and if they're in the water or what they may be doing. One of the next approaches, which is really the emerging approach, which Jason and Chris will each be talking about, which is the use of closed circuit television cameras, particularly with the advancement of artificial intelligence, which has really revolutionized this approach. These approaches can be used at a site or a sub-site scale, depending on the area of coverage of the camera and the size of the particular site. They can provide really excellent temporal coverage of what's going on. So regardless of whether services are provided or not, you can get a really good profile of what's happening over the course of the day and what's happening over the course of the season as well, and provide you really good data as to when you may want to target your services to be most effective. However, this technology is still developing, and there's a number of inaccuracies in some instances in these approaches. One great consideration, though, is this data is likely to improve with the advancements in camera technology and artificial intelligence. Next approach is really taking it to a slightly larger scale and looking at what other technologies we may be able to utilize. In one of the discussions previously, drones or unmanned aerial vehicles were mentioned. There's a real opportunity to utilize these equipment to capture data at a site scale or potentially a multiple site scale. You can cover a relatively large distance relative to cameras and capture this information on the number of beach and water users when combined with artificial intelligence. However, this approach, in contrast to the cameras, you can capture a large area, but the actual temporal resolution or temporal coverage is very limited. It's limited to the amount of flights that you're actually undertaking. You won't get a profile of the whole day unless you're constantly flying throughout the day. In addition, there's a number of operating limitations with these, whether that be regulatory or environmental, with wind limits and the like for safe operations. However, particularly in areas such as New South Wales, where we have the Australian UAV service operating for shark management, there's opportunities to utilise this piece of equipment and these technologies for multiple purposes across various facets of your environment, whether that be coastal erosion, beach counts, shark management, a range of opportunities there. When we scale things up, we can also look at other options and look outside the box of what we're trying to capture and why. But once again, there has to be a reason why we're trying to do this. What questions are we trying to answer? High resolution aerial imagery has some opportunities. They have an extensive spatial coverage. However, there's a low temporal resolution. So there's relatively few images captured relative to lifeguards collecting every hour, perhaps on the beach, or cameras collecting constantly. But with these technologies, there is the ability to analyze the spatial distribution of beach and water users along a section of coastline and spatially map areas that are higher density and lower density. There is also the ability to compare water users at a considerable number of beaches. So we can use this technology, which is captures a large number of beaches in one capture, and we can compare these sites to one another. Along a stretch, which beach is the busiest and which is the least busy, and by how much, using the same approach. However, I've presented a number of different options here, of which Chris and Jason will talk in more detail around specifically the cameras. I would suggest in many respects, the most suitable method depends on the questions you're asking, and a mixed method approach could be appropriate. It doesn't have to be one solution or the other. Some of these things can work together and be interchangeable and interlinked with one another. So worth considering. One thing that I mentioned at the start, I would delve in slightly into the vulnerability component at the end. So the exposure is really where we're capturing numbers. Vulnerability, we wanted to look in a little bit more detail around the people using that environment. Because many of these methods that I've mentioned thus far, they're only collecting numbers. They'll tell us that we have 100 people at the beach at this specific time, or on the beach and in the water, for example. We have very little detail, typically, in what other information we can pull from that data around the who. And these techniques really assume that everyone is equally vulnerable. But we know this is not the case. These different groups are at different risks of getting into trouble, or different levels of resilience, if you like. Therefore, we need to understand the demographics, as well as the residence and activity profiles of beach and water users at different sites. And how does that change across the season and across the hours of the day? Are we seeing particular groups in the morning, and how does that change to the afternoon and evening? Does that change our risk profile? To do this, we then need to understand the vulnerability of these different groups. Those surfers have a different level of resilience to the tourists who come in once per year, for example. And then we need to basically incorporate these components into our risk modeling. They're a really key component. So I'm just going to give you, just to illustrate some of the stuff that we can look at to the future, both in the technology and non-technology approach. I'm going to provide you a brief overview of some data that we actually captured a little while back in New Zealand. And this data was captured just by some surf lifeguards doing a small pilot study, collecting some observations of beach and water users over a 2-week period, capturing data on the geographic location, activities, gender, age group, ethnicity, and perceived resilience of particular groups using an environment. We also undertook some in-depth surveys at a smaller number of beaches to gather information on the knowledge, behaviours, and resilience of particular groups. And then we can compare these with some incident statistics and map some of this information spatially. So this small study was undertaken at a number of beaches in the northern part of New Zealand on the North Island, on a range of different beaches, a number on West Coast beaches, Northeast Coast and East Coast. West Coast is dominated by high wave energy. The Northeast Coast is what you would say moderate wave energy, and the East Coast beaches in there are low wave energy. So very different physical environments, close to New Zealand's largest city. With these observations, we managed to get a little bit of data in and around who was using the beaches. Based on some random sampling across the beach, who were the typical users of those beaches at those times. What we found was across the different environments, they were largely quite similar, 55 to 60, 40, male to female beach and water use at these particular times. However, there was some variation depending on the type of beaches that the observations were captured at. If we then compare this to the incidence statistics for these particular locations, we found that even though males made up more beach and water users than females, they were also still overrepresented in the incidence statistics. Okay, so anything above the line here, an overrepresentation relative to beach and water users. Anything below the line is underrepresentation. At all sites, males, despite making up 55% of beach and water users, they actually made up about 2/3 of those involved in incidents. Conversely, females were involved in less incidents in proportion to the use. So this can start to tease out some of the things that we want to understand about vulnerabilities. Secondly, we captured a little bit of information on the age breakdown of those using these environments. And we basically saw quite a mix across the spectrum in terms of the proportion of people of different ages using these beaches. One, I guess, that stands out is on West Coast beaches, a very high proportion of those aged 21 to 30 relative to the other sites. So many people in 21 to 30-year-old age groups are using the high energy beaches in large numbers. But we had a distribution across the age spectrum. When we compared these with the incidence statistics, then we could see, once again, above the line and below the line. Below the line, even though we had a number of people using these environments that were of the younger age group, those under 10 years old, they were actually underrepresented in the incident statistics. This indicates that parental supervision is likely very effective at these sites. Not to mention surf lifeguards, surf lifesavers likely intervening and undertaking preventative actions prior to incidents occurring. However, those above the line at all sites are highly represented in the incident statistics of those aged 16 to 30 years old. This really aligns with our thoughts in and around those that are taking greater risks, perhaps going further out in the water and perhaps underestimating the conditions and overestimating their abilities. We can also map some of this data spatially. So at a site, one of those lower energy sites on the East Coast, what we did was we mapped some of the stuff in grids. The way that this was recorded, we mapped out where the recreational use was across the beach. We've got a checkered box here of red and yellow, which was the flags at the time. And then we've got a distribution of different activities across the beach. We can see that swimming is predominant along much of the beach with some paddlecraft around the outer edges. We also mapped the perceived resilience of water users. What we can see in this, with red and orange being those perceived to be at higher risk or a lower level of resilience, if you like, thankfully a lot of them are in and around the red and yellow flags. However, we also saw some out by the mouth of the estuary, which I guess is of more concern at this location. So that's just I guess a brief overview of some of the stuff that we can look to capture now and into the future. We want to really capture all the stuff on the numbers, but really push the envelope beyond that and try to understand a little bit more incrementally around who is using the beach, how are they using it, what types of people are using it, and how does that vary throughout the season and across the hours of the day. It's really critical to understanding how we may best intervene, how we may best target education initiatives at these beach and water users. And I guess just in summary, there's a considerable number of methods that we can look at to capture exposure. The real critical question that we've got to bring it back to once again is what questions are you trying to answer and what swathe of methods may be best suited to answering your questions. We also need to ensure that we really utilize technology to assist us in this approach. We really want to let the research lead the way, to be filled in by technology. We don't really want to be letting technology lead us, and then we end up with putting things in place that really aren't answering the question and aren't fit for purpose. Really appreciate your time, and